I'm Ethan Kwan, and today I'm going to be showing you forces of a block of ice and whether this will start accelerating or not. So basically the title of this video is forces on a block of ice, basically, or something like that. Anyway, I haven't decided the title yet. Okay, so here we have a block. Here we have a ramp made of ice, and if you can't see the ramp, it's the light blue one. This one, the one that is okay. So and then there's a block of ice on top. I'm making everything out of ice in this video because we are gonna assume no friction whatsoever. So there will be absolutely no friction between these surfaces at all. Not even a smidge. Wait, let me just draw some. I don't know why I'm doing this. There we go. Okay, so no friction. Okay, why did I do this? Why did I sign up for this? Anyway, okay, so we're gonna assume we have this block of ice. Okay, and we want to figure out what the acceleration on this block of ice would be. I guess that's a good title. Acceleration of a block of ice. Not really, kind of boring, but anyway, I guess that's what I'll name it. Okay. Anyway, okay, so let's draw all the forces that are acting on this block of ice. Well, there's obviously the force of gravity, so I'm just going to draw that like this. So that's the force of gravity, and I'm going to label it force of gravity. Okay. So now we have force of gravity here, and okay, so there's also a normal force, but a normal force is a contact force, okay? But before I figure that out, let me just tell you that one more thing. This block is 10 kilograms, okay? So if that's 10 kilograms, what's the force of gravity? Well, that's pretty easy. That's going to be, force of gravity is going to be equal to the gravitational constant near the surface of the Earth, which is, what is it? 9. One sec, let me color this differently. I like switching colors, okay? Don't judge. 9.81 times, actually that would be 9.81 meters per second squared, okay? And then there's also going to be a, oops, no. Scroll over a little. There's also going to be a force for the mass of the brick, so 10 kilograms. Okay? So now we have this, and okay, so what is this? Well, it's going to be 9.81, or actually we're going to ignore the 1 in this case. We are going to, we're going to round, okay? And we are going to round to the nearest tenth. So we're going to ignore this 1. So it's just 9.8. 9.8 times 10 is 98. So the force of gravity on this block is going to be 98 meters per second squared kilograms, which is newtons. Okay? So the force of gravity on this brick is going to be 90 98 newtons downward. But this isn't the only force. Well, so next what we're going to do is we are going to break this force up. Okay? And let's assume that this angle right here is 30 degrees, okay? So we know that if we just do a force that is horizontal or parallel, or no, I don't know what this is. One sec. Perpendicular to our surface here. What is that? That? Something like that. Yeah, something like that. Okay, so that is going to be our force vector vertical to our plane, right? Okay, so So we are going to assume that that is there. And we are also going to put another force vector that is, boop, like that, okay? Okay, now what we're going to do is we are just going to take this block of ice, or that force vector, and stop selecting that. Don't select that. There we go. Darn, it selected the... Okay, there we go. Now we're going to move this down this way so that it lines up like that, okay? Okay, so now let's zoom in on this little part here. Actually, let's zoom like this, okay? So, what is... Well, here's a question for you. What is this angle here going to be? Well, that's going to be, well, there's a basic rule in geometry that you should never forget. That, oops, forgot to line. Okay, here's our line. If we have two perpendicular or parallel, I guess, parallel lines, and we denote them like this, that they are parallel, okay? If we have a transversal going along those parallel lines, let's use this color, like this, okay? This angle right here is equal to this angle right here. That's just a basic thing, so we can just denote that these are the same, like that. Okay, so if we use that rule, it's kind of hard to see here, but if you look, this line right here and this line right here are parallel, right? And if we extend this line and extend this line here, you can view this line, this one right here, this line right there is a transversal, okay? So if we do that, that means that this angle right here and this angle right there are the same, right? So we're assuming this is a 90-degree angle, okay? So what is this angle? Well, this is going to be 90 minus 30, or 60, okay? Okay, so now let's zoom in on this little section here. Okay, so we know this angle right here is 60 degrees, right? Okay, so we know this is a 90-degree angle, right? Given by our definition, right? So if that's 60 here, if this is 60, and this is, well, what is this? 90 and 60, this is going to be 90 minus 30, so we subtract 90 from both sides. So this angle right here, moment of truth, is 30 degrees. Actually, let me make that pen smaller. 30 degrees. Yay, okay, so we figured that out. Okay, so now we can use basic trigonometry to figure out this, right? So what we're going to do is we are going to take this, that, and 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 that. Yes, that's it. So we're going to copy that, and we're going to bring it down here, and we're going to paste it. Okay? Did we get everything? I don't think we got everything. Oh, well, it's okay. We're going to rotate this so it looks like this. Nope, like this. There we go. Okay, so if we rotate it like this, it looked kind of weird now, so let me draw it again. So it looks like this. Oops, I need a line tool. Something like that. And that. And, whoops, and that. And that. Okay, so that's what it looks like. And we just figured out that this angle right here is 30. Okay, so, and this is a 90-degree angle, so we can just use simple trigonometry. We're going to assume that we know the force of gravity, right? That's what it was. Force of gravity, we know the force of gravity, and let's call this length, what was it? Well, the long side was this one. So the longer one is going to be, this one. This one right here, we're going to call, well, that was the one that was right here, right? So that was basically the one that goes down, right? So we're going to call this one the force of gravity that is perpendicular. And this is the sign for perpendicular. I guess it kind of makes right angles. Okay, so what is this equal to? Well, if we use trigonometry, we'll get that. Okay, so this is going to be cosine. We're going to use cosine, right? Because we know the hypotenuse and we know the angle here. So we want to figure out the adjacent side. So it's going to be cosine is equal to opposite over adjacent, right? So adjacent over hypotenuse, sorry. Cosine of 30, 30 is equal to, hypotenuse, adjacent, we know the adjacent side, oh, we don't, we want to figure that out. Force of gravity that is perpendicular divided by force of gravity, right? Okay, so this here, we can multiply both sides by force of gravity to get force of gravity cosine of 30 equals the force of gravity that's perpendicular, sorry. Okay, so that's that. Now let's call this length right here, force of gravity that is perpendicular, and that's the symbol for parallel, sorry. So force of gravity that is parallel is equal to, and same logic, only we're going to use sine this time, so it's going to be force of gravity sine of 30. Now you can do the math if you want, just follow the exact same steps as before. Okay. Haven't switched colors in a while, so let's do that right now. Okay, so now we know this. Now, actually, we can figure out what force of gravity is. We actually already did that. Let's zoom out. We already did that right over here, right? So it's 98 newtons. Oh, that's tiny. Okay. So 98 newtons. So it's going to be force of gravity sine of 30 is going to be 1/2. That's just one of those things you have to memorize. Cosine of 30 is square root of 3 over 2, okay? So now we have these two values. So now we can say that force of gravity that is perpendicular, like this, is equal to root 3 over 2 times force of gravity, so 98 newtons, right? Okay, so that's that, and the force of gravity that is perpendicular, or parallel, is equal to 1/2 98 newtons. Now, the easiest one to solve here is 1/2 98 newtons, which is just 98 newtons divided by 2, which is 49 newtons. So, no, wait. Force of gravity that is parallel is going to be 1 over 2 times 98 newtons, which is going to be 49 newtons. Okay, now let's figure out the other one. Force of gravity that is perpendicular is going to be equal to, well, we can just bring this up here to the top. So root 3 times 98 newtons divided by 2, right? So 98 and 2 cancel, so you get 49 over 1. We can ignore the 1, so you're left with 49 root 3. Okay? So now we have force of gravity parallel. Force of gravity parallel is equal to, perpendicular, sorry. Perpendicular is equal to 49, no, not 49. It's going to be 49 root 3 newtons, right? Newtons, right? Okay, so now we have these. Now, what was our original question, right? What was our original question? Well, our original question was, what is the acceleration of this block? Well, we can figure that really quickly right now. Let's just zoom in again. Okay. And so we can just figure that out really quickly right now, because it's really easy. We know that force equals mass times acceleration, right? So we have F equals ma, FMA, that's how I remember, or FEMA if you want to consider this as an E. Oops, nope. If you want to consider this as an E, I call it FEMA. Anyway, oops, sorry. So just remember FEMA, kind of like female, or FEMOA. Okay, this is not the point of this video. Okay, the point of this video was to figure out what acceleration is. Okay, so let's divide both sides by mass, and you're left with force over mass is equal to acceleration, right? So we know the force, right? The force is, well, we just need the force that is like that, right? That's all we need. Yes, that's all we need. Yeah, that's all we need. Okay. So we need to input this 49 newtons in, and you're left with, we know the mass, so it's going to be 49 divided by m, or actually, let's put the units in. 49 newtons, which is kilograms, meters, kilograms, meters per second squared, divided by 10 kilograms. Okay, the 2 kilograms cancel, and you're left with 4.9 meters per second squared. Woohoo! We did it, you guys. This block, with no friction or anything, will start moving this way at a speed of 4.9 meters per second. Woo! Yeah! Okay, good job. Okay. I'm just dragging out a plane, yay! And a campfire, and a camper, a happy camper. Okay, anyway, why am I doing this? I'm not sure. Okay, so, I hope you liked this video. If you did, please subscribe, like, and share the channel with others. If you did also like this video, oh wait, I already said that. Thank you for watching. I hope you liked this video. I already said that. See your hazardsofleasing.com, and see you next time. Bye.